Chapter 11 is all about sampling data, and it's a lot of vocabulary. So making sure you just understand what each concept is talking about. There's really not a ton of problems. It's more just understanding all the different vocab. So section A really doesn't even have an example. It's just the vocabulary. So you might just want to pause the video and get all of this vocabulary done, and it'll just be easier for you to do this without me talking. Let me skip one. Okay. So then section A is about errors in sampling. So there's 4 types of errors. You can make a sampling error, you can make a measurement error, a coverage error, and a non-response error. So once again, you might want to pause the video. Sampling error occurs when a characteristic of a sample differs from the whole population. Measurement error refers to inaccuracy in measurement. Coverage errors, when the sample does not truly reflect the population. So each of these kind of gives some examples. Just write as much as you feel you need to understand this. And finally, a non-response error occurs when a large number of people choose not to respond. Think about that. How many have you ever been called for a survey? You just ignore it a lot of times. Online surveys, a lot of people just kind of don't deal with it. And that's section A. So it's just kind of answering questions about each of the different types. Okay, section B, we're going to look at the different types of sampling. There's many different types. And I don't know if you want to, I know I didn't really make room, but you might want to write each of these. Well, we kind of look at each one separately, I guess. Okay, so simple random sampling. Basically, I just wrote this right here. Each member of the population has the same chance as being selected in the sample. So the population is everybody. A sample is just randomly picking so many. So everybody's got an equal chance. I always love their pictures here. But you just reach in and grab a ticket. Okay, so you can actually generate random numbers on your graphing calculator. So if you go to Math and choose the Probability tab, and then the first option on there is Rand, and that's for random. And what this example shows is we're choosing a number. You make this be the first number that could be chosen. This is the last number that could be chosen. And this is the number of numbers you want to pick. So in between 1 and 30, if I want to choose 3 numbers, the calculator chose those 3 particular values between 1 and 30. So that's just, you may use that in college if you take a stats class, but I don't know that we've ever used it. But it's kind of fun to see what the different buttons do. All right. Systematic sampling. I have a lot of different things on here that I think I have a lot more notes or flip charts that I have on your notes. So just kind of make do. Okay, so in a systematic sampling, you're just, what I wrote is you just pick every so many members. So like in this example, they're picking every number that ends in a 3. You could pick like every 10th number, every 5th person, things like that. Systematic is just you're picking every so often. Okay, so management of a large city store wishes to find out whether potential customers look like the look of a new product. They want to sample 5%. So let's think about that. 5% is your 5 out of 100, which is 1 out of 20 people. So you just sample every 20th customer. If you do every 20th, then you're getting 5%. So whether you have 100 customers that day or 500 customers that day, if you pick every 20th customer, you're going to have 5% of the population represented. All right, convenience sampling. Basically, it's just whatever's easiest. Okay, they're selected because it's easiest to select. Who's walking close to them? Who's slow that you can kind of run up and catch to? These are just convenient for the experimenter. I will tell you, convenience sampling is not going to be super reliable. All right, so stratified. I actually looked this up because, this kind of shows you different things, but I'm going to write it this way. It's a population can be divided into subgroups. So you're going to divide everybody into a subgroup, and then you choose out of each subgroup. So you have a population, you have 4 subgroups, you pick 1 out of each one to create your sample. All right, so for example, I'm going to move this down. So there's 137 students in the school in year 8, 152 in year 9, 174 in year 10, 168 in year 11, and 121 in year 12. If we want a sample of 50 students, how many should we select? Well, each subgroup needs to be indicative of how many kids are in each subgroup. So the first thing we're going to do, add up to find the total. And there are 752 students in the school. So if we want to figure out how many go in year 8, I'm going to take 137 divided by the total, multiply that by 50 to see out of my 50 how many will be out of year 8. And I get 9 students. In year 9, there are 152 students. Out of 752 times our total sample, 10 students are going to come out of year 9. Year 10, we have 174 out of 752 times our 50, and we get 12 students. In year 11, I have 168 students out is 752 times my 50 to get 11 students. And out of year 12, we have 121 out of 752 times our 50, and there's going to be 8 students. So the number of students in each subgroup should be indicative of how the percent out of the total. That's why you find your percent out of the total for each one times the sample number to get your total.